Hello, so today we want to consider range and domain of functions. To begin with, we need to define what domain actually is. You see, the domain of a function is the complete set of all possible values of the independent variable. It's common in mathematics to use x for the independent variable. Let me explain this now. You see, if we have y is equal to 2x, you see the x here is actually called the independent variable. Independent. It's independent because you just assume let x be 1, then you get the value of your y. Let x be. So you see, when you're saying let x be, it means that you didn't solve to get that x. You just imagine that x. It's independent. It doesn't depend on anything. But you see this y. The y is called the dependent. And the reason is because the value of x you put will determine what your y would be. So when we talk about domain, we're looking at all possible value of the independent variable. I'm saying independent here because it's not necessary you use x. You can be using t, v, whatever value you want to use for the independence. But in mathematics, it's common we use x. And so all possible value of x, that's what domain is all about. All possible value of the independent variable is what domain is all about. And now we need to understand that when we talk about domain, there are different type of functions. First of all, functions means relationship. That is a relation. This is a function now. Y as a function of x or y equal to 2x is a function on its own. Function just means mathematical relationship. That's what function is. So when we hear function, it doesn't look like something strange or abstract. So that's about that. So there are different type of functions. Now, if you look at this, now this is just one type of function. And if you look at this function now, I'm going to ask myself, are there values of x I would use that wouldn't make me have a real answer for y? And the answer is no. Even if you use 0 here for x, 2 times 0 will give you 0. 0 is actually an answer. 0 is a number, a defined number, a number we work with. So if you use minus 1000 for x here, you would only get y to be minus 2000. If you use value of x here to be 5, you will get y to be 10. So any number, real number you can talk about, if you use any of those real number for x, you have a value for y, because this is how this function is. A very simple function. But there are other functions where you cannot use any number you want for x because you wouldn't have an answer. And that's what domain is all about. Trying to avoid those numbers that wouldn't make you have an answer. So we have some few cases actually. We didn't highlight all of the cases, and that's because the questions we'll be solving here are only restricted to the few cases you can see here. Now, for the first one, he said, when the function is a fraction, the denominator must not be 0. For instance, if I say y is equal to 1 over x, for instance, now, you need to understand that you can't just use any number you like. Here, we could use 0. You cannot use 0 here because 1 over 0 becomes undefined. And so you wouldn't have answer for y. So as a mathematician, I needed to let you know that, see, 0 is you must avoid 0 here. That's why you see, when we write things like this in mathematics, we say when x is not equal to 0. That's a kind of domain, a kind of way of writing domain, that x must not be 0. So you know that when taking this function, you must avoid 0. It's already stated. That's what we're talking about. Again, is that the square root of a negative value must be avoided. You see, if I say, for instance, y is equal to root of x, I'm just taking the basic ones actually. Y equal to the root of x now, square root of x. You understand now that x cannot be negative. If you have square root of a negative number, you are not going to have a real value for y. If I put root of minus 1 here now, you won't have a real value for y. Some will say probably you have the idea of a complex number, but when we are doing range and domain, we are concerned with just real numbers and not complex number, imaginary numbers. And so x cannot be negative. If you put x as negative, even if you use your calculator, you can check it. It's going to give you math error. So you can't get that. Again, is that for a logarithmic function, if I say y is equal to log x, for instance, now, understand that you can't use 0 for x. If you check log 0, you will have math error. And again, if you check for log of a negative number, maybe minus 1, minus 2, minus 3, minus 1 million, you won't have an answer. So we want to avoid anything that will not make us have answers actually. So that's what the domain is, and we state it clearly. Let's say avoid so and so numbers because it's not going to give you a real value for your y. That's what domain is all about. Now we need to talk about range. See, the range of a function is a complete set of all possible values of the dependent variable. What we mean is this, like I said earlier, using y is equal to 2x, and I said that y is independent. Now we want to see what are the answers that are obtainable depending on the value of x we use. Are there values of y we cannot get because y is usually the dependent? So some functions y can never be negative, and so because of that we are looking at what are the possible values that y can be and possible values that y cannot be. For instance, now if I give that y is equal to root of x, I need to understand that nothing will ever make y negative for this kind of function. In mathematics we were taught that y is equal to square root of if y is equal to square root of 9, that the answer is plus or minus 3. No, that does not work when we talk about range and domain. The square root of 9 is just plus 3, not minus 3. And that's because, you see, you cannot have two answers. When we come to range and domain, we cannot have two answers for one question. You cannot say he is a boy or he is a girl. The same way too, when we take square root of 9 here, we're just saying it's just going to be just one single value. And that's because a function actually cannot have two range. Range means the possible answers. If a single function has two range, it's no longer qualified to be a function. That cannot be a legitimate function. That's under this study actually. And so when you're doing your general form mathematics or quadratic equation or any other thing, square root of 9 can be plus or minus 3. But under this study, range and domain of functions, no, it's not allowed. So have that in mind. So I'm trying to say in essence that square root of x now can never give us a negative value. So you can't get y being negative for this kind of function. So under range, we are considering what are the possible values that y can be, or what are the possible values that y cannot be. And so we have that in mind. Bringing out all possible value of y is what we call range. It's better to use the word dependent, and that is because not necessarily that this thing must be y. It could have been v is equal to something. So we're using y because we are used to using y as our dependent variable or our output in mathematics. So but that's that about range and domain. And these are the steps we take. The first thing we do is to make x the subject of formula. And after we do that, we now check the value of y that wouldn't give us an answer for x. So as we solve for range and domain in any question, we'll be using all of these tips to get the range and domain. So now we understand that range and domain is concerned with all possible values of x, or the independent variable, and possible values of y, which is dependent variable. Now, another thing to take note is that, you see, as we look at the number line, the middle of the number line is 0. To the extreme left, what we have here is negative infinity. And to the extreme right, what we have here is positive infinity. Now, I'm going to explain this. You see, there is no end to the negative number. If you get to minus 1 million, if you continue, you will get minus 1 million and 1. And if you get to 1 billion, if you continue, you get minus 1 billion and 1, minus 1 billion and 2. And if you get to 1 trillion, you will still get to minus 1 trillion and 1, minus 1 trillion and on and on. So there's no end to number. So we're assuming that the last bus stop for negative number should be negative infinity. Nothing can take this value actually. Because infinity is not something real. It's not actually a particular value. But we say, let that be the last bus stop for negative number, negative infinity. And then to the positive numbers as well, the same thing happens. So let's assume that the last bus stop of all possible numbers now should be the positive infinity. And so you understand that the middle of this now should be 0. Example 1. Obtain the range and domain of the function y equal to x plus 1. So let's solve this now. Let's take the domain firstly. Now remember again that domain talks about all possible values of x or the independent variable. Now the first thing here is, are there values of x if we use that won't have value for or answer for y? If you use any negative number, use minus 1000, you will have answer for y. That will be minus 999. If you use 0 for x, you still have answer for y. If you use any positive number, you have answer for y. So you can use any possible value for x or y. Any possible value for x, you will have answer. So in that case, our domain is negative infinity less than x less than positive infinity. Mean that our domain ranges from all negative number to all positive number, to the two extreme. Now, if you watch here carefully, we say x is greater than negative infinity. I'm not going to say s is negative less than s is greater than or equal to. No, that's wrong to say when you talk about infinity. Why? Because s cannot actually be infinity. And the reason is because infinity is not actually a number. Remember. And so the same way to x less than positive infinity, I wouldn't put less than or equal to. So why? Because positive infinity is the extreme number for all positive number, and then infinity is not actually a number. So because of that, you just use this symbol. Another way to write this is to say negative infinity comma positive infinity, like this. So this is how to write the domain. Next is to write our range. Now, to obtain our range, one thing to do is you can make the x subject of formula. So that means to say the question comes with y is equal to x plus 1. Then I can say that x is equal to y minus 1. Now I'm going to ask myself, are there values y cannot take that if I use for y, I won't have answer for x? The answer is no. There's nothing that y takes here that will not give us answer for x. Because of that, x takes all possible values. Y can take all possible values actually. So there's nothing y cannot be. That's what I'm trying to say. And because of that, we're going to say that the range is simply negative infinity less than y less than positive infinity. Or we still write it like this: negative infinity comma positive infinity. So this is another way to write it. So that's that for this example 1. Example 2. Obtain the range and domain of the function f of x is equal to 1 over x. Okay, so let's solve now. As we look at this, we can say let y be equal to 1 over x. Now, our domain. The first question need to ask is, are there values that x cannot take? If x takes such values, we won't have an answer. Because this is a fraction. Remember we said when we're talking about our domain that for fraction, you must avoid the denominator being 0. And the only way the denominator will be 0 is when x takes 0. So x must not be 0, because if you have 1 over 0, you won't have an answer. And so 0 should be the only number that should be avoided. Any negative number will work. If I put minus 1000 here, I will get y to be 0.001. That's an answer. That's a value. But if you put 0 here, you get undefined. So 0 cannot be part of the values of x. How do we now write this? Any positive number will also work actually. If you use 1 million, you get 0.000001. That's an answer. So only 0 will not work. So we write like this: any negative number less than x less than 0, and then union this union 0 less than x less than any positive value, positive infinity. This is how you write this actually. Or you write like this: minus infinity comma 0 union 0 comma positive infinity. This is another way to write this. So you are simply telling us that negative infinity to 0, s cannot be 0, s cannot be infinity, but in between those two, yes, s can be. S cannot be 0, s cannot be positive infinity, but in between those two. So from 0 to all positive values, s can assume that, apart from infinity and 0. And between on any negative value and 0, s can assume that, but must not be 0, cannot be negative infinity, must not be 0, cannot be positive infinity. That's what we are trying to say here. Now let's take our range now. To get our range now, we have to make x sort of formula. So we have that y is equal to 1 over x. Hence, we can now say that x is equal to 1 over y. Now, with this now, we can tell that y2 cannot be 0. If y takes 0, we're not going to have value, an answer for x. But y can be any negative number. Y can be any positive number. So the answer comes exactly the same, like this. So our range is still going to be negative infinity less than y less than 0 union 0 less than y less than positive infinity. So that's that. Or you say minus infinity comma 0 union 0 comma positive infinity. So that's that for our range for this question. And if you watch our example 1 and example 2, our range and domain is always the same, but not always so when we solve other questions. Sometimes the range and domain is the same, while in other cases, range and domain may not be the same. Example 3, find the range and domain of the function y is equal to 1 over x minus 1. This is another function that is a fraction. Now, to solve this question, we need to ask ourselves, that's to get our domain, what are the values of x that wouldn't make us have an answer here? Remember, if it's a fraction, the denominator must not be 0. So if the denominator must be 0 here, what would x take? It's very, very simple. Just take this denominator here and equate to 0. So that is x minus 1 equal to 0. And you see that s is equal to 1. So it means that if x is 1, that will give us 1 over 0, because that will be 1 over 1 minus 1. And that's 1 over 0. So x must not be 1. But s can be any other thing. If you put minus 2 here, you will get 1 over minus 2 minus 1. That's 1 over minus 3. And that gives us minus 0.33333. If you put minus 1 million here, you will still have an answer. Minus 1 billion, have an answer. Minus 1 trillion, you have an answer. Any negative value you use. And any positive value, any positive number you use, you still have an answer actually. But x must not be 1. Because of that, how do we write it? Very similar to this. I'm going to say negative infinity less than x less than 1 union 1 less than x less than positive infinity. So this is how our answer is. Or you say minus infinity comma 1 union 1 comma positive infinity. So this is our answer. Now let's do our range now. Remember, to do our range, we need to make y sort of x sort of formula first. So I interswitch this now. If that happens, you get x minus 1 is equal to 1 over y. Now bring this here, you get x being equal to 1 over y plus 1. Now the question to ask is, what's the value of y that wouldn't make us have an answer for x? So y cannot be that value. If you look at this carefully, you understand that y, if you put 0 here, This will give us 1 over infinity, 1 over 0, and that will be infinity. And infinity plus 1 will still give you infinity. And so understand that y must not be 0 in this case. That's just what to avoid, because this is a fraction. In that case, we can now say our range can be any negative number actually. So, but must not be 0. In that case, you see that we have minus infinity less than y less than 0. Then union 0 less than y less than positive infinity. So this is that for our range. And you can write like this: minus infinity, comma 0, union, then positive 0, comma positive infinity. Now you can see that our range and domain is not the same here. So that's that. Let's take another example. Example 4. Find the range and domain of f of x equal to x squared plus 5. And so solution, let's just say y is equal to x squared plus 5. So now, to get our domain, so the first thing I'm going to say is there any value of x is there any number s would take that wouldn't make me have an answer for y? As we look at this now, any negative number you use, you have an answer for y. And any positive value you use, you also have an answer for y. There's no restriction to what y can be. So it's going to look like this. From any negative number to any positive number would work. That's our domain. Or you say minus infinity, comma positive infinity. That's that. Now, to get our range now, remember you make y sub formula, x sub formula, sorry. So this is going to be x squared is equal to y minus 5, and then x becomes square root of y minus 5. Now, having this now, I'm going to ask myself, are there values that y would take that we wouldn't have an answer? Remember when we have a square root function, we say that whatever is inside the square root must not be negative. Now listen now, if you use y as 0 here, what happens? 0 minus 5 will give me root of minus 5. Now, because everything becomes root of the minus 5, you won't have an answer. If you use 4 as y here, what would happen? This will give us 4 minus 5, that's minus 1. And so whenever you have a root function, the thing to do is that try to avoid anything that will make you have anything negative here. And the best way to do it is to say y minus 5, the things inside the square root, y minus 5 should be greater or equal to 0. That's how to do it. Because whatever is here should not be negative. So if it's not going to be negative, it should either be 0 or greater than 0. And so if you do that, this one comes here. You see that y is greater than or equal to 5. So y begins from 5 upward. Now you can see if you put 5 here for y, what would happen? 5 minus 5, and that will give you 0. Square root of 0 is actually 0, and that's an answer. So y will take values from 5 upward. That's what it's simply saying. And so because of that, our range, will look like this. Anything from 5 to any positive value. Now, why is negative excluded? Remember I said, even if I put, just imagine here now, let's say we put 14 here. 14 minus, for y, 14 minus 5 will give us what now? 9, right? And then square root of 9, remember it will give you only plus 3. So once you have square roots, understand that you cannot have a negative answer. And you can take that from here. Now there's no value of x you will put that will make you have negative value for y. Even if you put minus 1000, by the time you square it, it turns positive eventually. So nothing will make y negative. So it still works with what we have here. So y cannot be negative. So y is only positive value, and that positive value must start from 5 upward. How do we write that? We say 5 less than or equal to y less than positive infinity. Now, the way we write this, because y can be 5 but cannot be positive infinity. This is how we write it now. 5. This thing here, you see, I didn't use this kind of bracket here. Why? Because this thing means 5 inclusive. 5 inclusive means that 5 can be one of the answer. That's why it's written like this. If you write like this, you are simply saying that it cannot be 5. But when you write like this, you are simply saying that 5 can be one of the answer. So there are two different things. I'm only going to use a bracket here if there was no equal to here. But since this is less than or equal to, this is what I will use. So from 5 to any positive number, but cannot be infinity. That's what our range should be. Example 5. Find the range and domain of the function y equal to x plus 1. So to solve this now, let's get the domain first. Remember now, this is a square root function. And because it's a square root function, I'm going to take what is inside the square root, that's s plus 1, and say it will be greater than or equal to 0. So eventually, x, if this one comes here, greater than or equal to minus 1. So it simply tells me that, you see, when we have square root, you understand that you cannot have anything negative here. And the only time, the least number you will use that wouldn't make you get negative is minus 1. If you use minus 2 here, you have negative, because minus 2 plus 1 will give you minus 1. And that will not give you an answer. So from minus 1 upward. So how do we write the domain now? Domain should look like this. Minus 1 to any positive value, because you cannot use any other negative value apart from minus 1. So minus 1 less than or equal to x less than positive infinity. So this should be minus 1 inclusive and then positive infinity with a bracket. Is how we write it. So we say, why do we put this bracket here? No, remember that there's a less than or equal to here, so it does not matter. Now for the range, we have to make quite a formula. So you square both sides. Now that will be y squared is equal to x plus 1. The square root here will go away. If you bring this one here, you get that x is equal to y squared minus 1. So here, as we look at this now, we understand that y can take any number actually. Y can be whatever you want to put as y. But remember, there's a square root here. And because there's a square root here, understand that y cannot be negative. So understand that y can never be negative. But y can be 0. Y can be 0. Y can take 0. I would have said y can take any negative number, any positive number, because of the square. We square here. But because of this square root, that has eliminated that. So y can be any positive number from 0 upward actually. From 0 upward, y can be. But y cannot be negative. So hence, we're going to say our range here is going to be 0 less than or equal to y less than positive infinity. And that is going to be 0 inclusive, then positive infinity. This is my answer. So that's about this question. So assignment, find the range and domain of the following 1, 2, and 3. So the domain of 1, 2, and 3, this is it. And the range of 1, 2, and 3, this is it. So this number 3 can be in this form, can be like this, or can be like this, any of them.